Hello and welcome to Inform Friday. I'm Leila Angelaka and I work for Historic Environment Scotland in the technical research team. This is the second to last session for this spring series, and we will be talking about a very popular subject that a lot of you have been asking about: damp issues in traditional buildings, how to deal with them, something that unfortunately a lot of building owners are familiar with, not just traditional buildings, but generally all buildings. As mentioned before, we will also introduce you to our Inform Guide series and other relevant publications that we offer. These publications are all available on our website, and the links to the publications will be posted on the chat. And please make sure you note them down so you can find them later. We have had two sessions already this spring, one about solid walls in March, and the previous one was about micro-renewables. These are still on YouTube, as well as all the other previous sessions, so you can catch them up on there. As usual, if you would like to ask us a question, you can do this now via our Facebook page or log into your YouTube channel with your Google account. The event will be recorded as always and available to watch anytime you wish to do so. If we don't manage to answer your question, or if it's something quite complicated and we would like to see photos, we would ask you to email us at technicalresearch@hes.scot, or we'll try to answer that at the next session, which is sort of an open question and answer kind of surgery. So today I will be giving an introduction to the key routes for water ingress, and Roger will join us in a second. And he will be showing some pictures with examples of damp issues, and he will talk around them. We will then also get onto the questions. So just to start off, I mean, we all know how damp looks like and why it's not very good to have damp issues. They can lead to health problems, they can lead to fabric decay, and it's even worse for energy efficiency or when you are actually thinking about upgrading your home. You need to deal with them first. So we need to stress out before everything else the importance of repairs and maintenance of your building. The building needs to be dry, free from any damp or penetrating water ingress. And we need to think how these buildings were built, which is something that we've talked about quite a lot. And here you can see a diagram that shows you to the right how a well-maintained gable should look like and how one that's is experienced a bit of disrepair may look like. So you can notice a few things like the chimney detailing, the skew copes, they're missing the joints. You can see broken downpipes, the raised ground levels. So there's a few areas that you need to kind of look out for. Because we're showing these images quite quickly, if you wish to look at them more carefully, they are on our adaptation short guide, which we will put a link down below. So a very important thing to note here is that traditional buildings have been designed with this sort of moisture and vapor movement in mind. So the materials that were used, like stone, lime, timber, and their construction allowed the movement of water vapor and moisture throughout the building, which is often referred to as breathability. And that includes also the evaporation of water or moisture, and that works both ways. So you'll see on that image, there's also the water or moisture coming from the outside, like the weather, but also there's a moisture load coming from the inside, from showering, sort of washing machines, or sleeping. So the building needs to allow this sort of the moisture to disperse and evaporate both ways, because persistent also wetting leads to masonry decay and internal defects. So how do you know you have a damp problem? Most of you will know. Some of the symptoms are darker patches of discoloration in internal linings or the external masonry. You might see salts leaking. You might smell sort of a musty smell, vegetation growth, especially externally. You might see flaking linings or paint, bulging plaster, at worst even rot. You can also feel cold to the touch sometimes, because that could be one of your indications, or you may see some condensation. And that's an image that shows a bit of, not just a bit, but some mold forming in the top corner of that room. So there's generally three main sources of water ingress: from the top, the side, and the ground. So what we're thinking about from the top is usually the roof and the rainwater goods, chimneys as well, skew copes, and especially junctions between different elements where the skew cope, for example, meets the roof. Symptoms, again, could be discoloration, mortar or masonry failure. Internally, you might see rotten timbers, especially under the roof. You might see vegetation growth at high level, and at worst, you might actually see a leak. Causes can be maintenance, usually, such as dislodged slates or broken or blocked rainwater goods, weather mortar joints, chimney stacks. But you could have a flat roof at the back, which may have been lifted. The same with flashing. It can be lifted, especially after strong storms. And especially the pointing on the skews or any other high-level detail in the masonry is quite difficult to monitor. So these are areas of weakness that are often overlooked, and they can just easily allow water in. And obviously the increased rainfall due to climate change doesn't help. So one main thing here is to note the defective pointing and detailing, whether that's missing or is defect. Some quick solutions that I can mention here, and then Roger can talk more about them. As we said, maintenance before everything else. Maintenance with appropriate materials. Fine lime mortar is usually the best, but it depends. And then you might need to think about adaptation. If your building is not coping with the water load sufficiently, you might need to think about changing some of the detailing for it to kind of cope better. We have had a previous talk on adaptation that's still available to watch on YouTube, and it talks a little bit more about what you could do to adapt your building. So here you actually see the chimney. Even if you're not using your fireplace, it's good to have the flues open. You can use vented cowls at the top just to maintain some air movement. This is an area where often there's a lot of debris in there, especially if the fireplace is not being used. And it's very easy for water to get in and sort of stay there. And so that's why we say just keep them open and keep the air going around. Here also you see there's a bit of overhang or drip detail to the chimney. That's the very top. Maybe you can zoom in to see what I mean. And that actually helps shed the water away from the chimney. Also, just below that, there is a little bit of an overhang to the gable. And again, that helps sort of shed the water away from those more sensitive or weak junctions. More, if your building needs just that touch more, you can cover the skew copes or partially cover them with lead. And generally the skew cope is usually flush with the wall, but it might need that additional overhang, as you see here, if your building doesn't have that. There are other solutions as well. If you need something more durable, you can put lead soakers underneath the slates or secret gutters in the junctions. So also, we've talked a little bit about rainwater goods in the past lives, and here again you can see one that's very clearly, you can see what the problem is, but the owner cleverly painted the downpipe to match the vegetation. So you need to kind of look at the building in a holistic way and see what you can identify. So secondly, as we said, water can penetrate the building sort of vertically through walls and gables. Areas, again, gables are kind of, I put them between the top and the side because they kind of take the whole elevation of the building. And other areas can be parapets that are defective or missing, areas around windows that they need pointing. And as I said earlier, these gables are the most exposed part of the building with the roof, so they're susceptible to driving rain. And with increased rainfall, they are becoming quite a common problem. If you can identify where the issue is, thermal imaging can often be useful. Other symptoms include vegetation growth, peeling wallpaper internally or bubbling paint, damp patches, sort of similar, I guess, as we talked about earlier. Causes is usually lack of maintenance or inappropriate repairs, and driving rain can penetrate through cracks or open joints. So impervious external finishes or harder mortars can crack more easily, so they allow the water to go through, go in, and then the water can't evaporate the way it should, so it kind of stays in there, and you have those damp issues. That, together with a lack of ventilation, exacerbates the problem. So you see the next image here, there's a little bit of vegetation, but it gives an indication of the issue. And the next image also will show the a tree that's very close to the wall. So that can also become an issue, although it looks quite nice and romantic often, it can create issues. So solutions, again, maintenance, repointing using lime-based mortars is generally considered the best solution, but again, should be carefully specified. For example, where you're talking about more exposed areas, like the top of the chimney stack, you might use a harder sort of cement or a more robust mortar. Sorry, not cement, robust mortar. However, I want to say that cement mortars inhibit the drying out process, and we generally don't recommend them. Similarly, waterproofers will not work long term, and they can also damage the masonry. So we always advise to just replace with traditional materials, and just using vapor permeable materials throughout the building, including internally the lining paper that you choose and the paint. So you can use clay paint, which is quite good. Externally, other things you could do is you can use lead trays under your seals, especially where there's no seal, like it's flush to the wall. You can use lead trays to direct water away, which we've shown on another live, and I think we have a picture of that later on. If you have a rubble masonry wall, it's best to flush point around that. And here actually is an image that it is internal, but you can see sort of that very hard cement based mortar that has been used throughout, and you can clearly see the damp issue there. And as mentioned a few other times before in previous lives, if you have watched them, you can always think about adapting your building. You may think that harling a gable wall could be the solution, even where the wall wasn't harled or wasn't finished in that way before. So the last thing is any sort of humidity or moisture coming from the ground, usually through capillary rise. Symptoms, it can be decay of internal linings, blistering of paint. You see here some issues with the timber. And that's usually where you identify that, but it can be mold, it can be tide marks, musty smell as always, and more extremely, you might see standing water externally or vegetation growth. Causes, it can be raised ground levels, which tend to kind of rise as years go by, and they also tend to block external vents. So you always need to check that your vents are open, free of debris or other obstruction. But there could also be changes in the water table. There could be an issue with below ground drainage, like blockages. So you should always check sort of all these areas to see what might be the cause. And sometimes new work can also result in a buildup of moisture, especially when impermeable materials have been used. So if you can go back a little bit, I think it's one photo before, you will see here what I was talking about the raised levels, and here the tarmac is up against the wall. You can clearly see the vegetation. So the solutions is, as we mentioned, reopen ground floor vents to aid ventilation throughout the building, or make them clear, because there's often quite a lot of debris that's not visible. Use vapor permeable materials throughout, including paint, as we mentioned before, as well as breathable carpet underlays if you do have a carpet. Also check below ground drainage by rodding or using pressure jets. But sometimes a French drain with using fine gravel or sand can be the solution and actually help if your issue is persisting. Generally, plastic sheeting should not be used because it's not vapor permeable. And for things like, in a one-off event, if you had a leak or a burst pipe, some drying out of masonry and timbers will happen naturally if the problem was one-off and has been addressed. You just need to allow the building to dry sufficiently. Impermeable sealants and solutions such as tanking will not usually solve the problem, as it's not really addressing the source of the issue, and the water tends to find ways to travel through the masonry up the walls, and also to more susceptible elements such as linings or timber linings. So generally, what we say is to have a sort of holistic approach when you're trying to identify the issue for your dam problem. Water is not always coming from the outside, of course, and it can also be a mains pipe or other internal leak. And also inappropriate installation works along with insufficient ventilation can cause condensation that could also lead to other issues. So, but we're giving you a few hints here, but you should, if the issue, is quite complex, we always suggest that you get an experienced professional who is familiar with traditional structures. So we will be putting a link to the RICS website, which is the Charter Surveyors, and they have a section where you can actually find a conservation accredited surveyor. So I think now we'll leave Roger to kind of talk about more specific issues around images, so maybe you can understand that better. Roger.
Hi team, and welcome back to another Inform Friday. So what we'll do now is rattle through a few images that we've come across during the last few years working on various problem buildings of different types. And I'll start at the bottom of the building this time, and we'll work our way up with a few examples of where damp was experienced and what the cause was. And generally, I'm afraid industry is quite keen on addressing the symptoms of the damp, but not really the underlying causes. And with traditional and older buildings, that's not well understood. Absolutely, the first point when people talk to me about damp is it the top of the building or the bottom? And if it's the bottom, I always ask about below ground drainage. Nobody likes to talk about sewers and drains because it's somehow not part of the building. It absolutely is. So here is an uncovered piece of below ground drainage on a very historic church, as it happens, in Fife. And they were complaining about damp in the nave in the middle of the church, and the place was cold, damp and smelly and pretty horrible, with sometimes liquid water coming in. And so we worked with the architects, and sure enough, after a little bit of excavation, we discovered that the below ground drainage virtually didn't exist, was full of holes, and the right hand of the two images you can see there, the water was actually being pushed, being routed literally through an open end into the foundations of the building. So it was absolutely no surprise that this was causing issues. Big bit of work to dig that out, and in fact the solution here was to sort out the drains, reroute the drains, and lower the ground levels around the church. So the next image gives a feel of how it looked like at the end, with a bit of gravel around the footing, taking the grass down. It was a graveyard, so there was a whole lot of questions and permissions to excavate, but actually we did that. And if we hadn't, I think the church wouldn't be quite so good as it is now. So moving on to the next little illustration then, and this one is really about water tables and possibly other people's drainage. The ground around this building, which is a church in Govan, had been used for tipping spoil from building sites just to off from the building where the picture was taken from, and all the water in the area was being run down into the lowest point, which was the foot of the church, and no surprise they had literally ponding water, as you can see. So that needed a really big approach to get proper new drainage in there to get the water away. So think about the water table and what's coming in and around your building, not just necessarily the building itself. The next image is actually from a correspondent, a person we've been discussing with their particular issues, and show what appears to show a kind of rising damp or some sort of staining on the internal plaster of below a window. And this is quite interesting because the masonry below windows is often quite thin, and therefore water running down the outside will pass much quicker to the surface. Depending on the type of plasterboard this is, or the type of plaster, modern gypsum will also absorb water from the air as well. And the real clue to this one is possibly, and I'm not necessarily sure I'm right, but it could be, is the staining, the slight algal growth around the windowsill and down the masonry. That stone is probably only a leaf thick, and I suspect the capillary draw is taking the water quite quickly back. I do see a vent right in the middle there, just to the right of the flowers on the left-hand side, and that suggests that there's a timber floor, or there was a timber floor. Is that vent open, and is that solum area underneath the floor able to dry out? And I wonder about that. Sometimes concrete floors have been put in, which inhibits the dispersal of moisture in the floor area, the solum area, or you don't have a solum anymore. You just got a big lump of concrete, which quite often pushes the moisture up the walls. So sometimes modern renovation techniques can actually cause the very problems they're trying to solve. What do you do about that? Well, again, it's harder to say without actually going to the building. But in one church building where you had damp on an area below the window, we put in a lead drip, which when the water ran down the window onto the sill, it was thrown clear of the wall, and that's made a significant improvement. Note that's a westerly elevation, and the previous image, I understand from the client, was actually from the east. But changed weather patterns may mean you're getting more rain from slightly different areas of the weather's coming from slightly different directions, which might put new pressure on. So that's kind of work in progress a little bit. The next slide shows cold spots in a bathroom when some linings had been removed. So quite often, if you inhibit movement of air around a traditional building, and you have hard painted or oil painted surfaces, particularly with cooler areas behind, you will be prone to condensation. So often that's a sign of damp masonry on the other side. It's quite a good tell, even if that actual material itself may not be wet to the touch at all. And moving on to another observation from a question from a correspondent in Calendar, and this is about this is probably a combination of factors. I always get a bit tweaked when I see asphalt hard up against a wall, because the footings of that wall can never dry out, and that might lead to raised humidity level in the wall itself. There may also be a concrete floor, and also, depending on the orientation, there may be drip detailing issues on the sill, although that sill has a reasonable projection. So again, this will be a combination of factors, and often the type of internal paint used and the nature of those internal finishes, including the ventilation under the floor, as I touched on. So generally, damp quite often is a combination of factors where each little element is not quite working as it should, which overall leads to a progressive increase in relative humidity and ultimately liquid water in the fabric. I think rainwater goods has been touched on by Leela, but that generally, as we move up the building, is a very significant area. Poor maintenance, blocked rainwater goods equals water coming out and falling down the walls or running down the walls. And the next slide will show you an image where a cast iron downpipe has been blocked, which actually is kind of not immediately obvious, apart from the fact that the walls become saturated and the plants are doing very well. Thank you very much. If you see plants on walls, it generally means the wall is wet enough to support plant growth, which means it's damp. And in this case, I think that's a cement render with an oily paint on it, and the stone margins have also been painted. So the inside of that wall is probably very, very damp inside, with all the issues that might be going on. Okay, so on the next image, we've got a block down pipe on a corner, and you can see some of the staining, the green staining lower down. that situation was about 2-3 years old. And then if inside the building, the staining showed up as the blistering wallpaper, lots of mold, and actually the coat hooks inside holding the coats, the timber there was actually rotting because the stone was so wet. So a lot of stonework is wet because of downpipe and detailing issues, and that angled junction at the top, sometimes called a swan neck, is quite prone to blockage. So if you see that, just think, right, I wonder if that's running free and clear. And if the stone starts to go a bit green, you know it's probably blocked. We did have a question about what to do about green on walls if they've been wet. And the short answer is you don't need to do very much. It stops being green once it stops living, and it falls away and disappears. Okay, so we'll just move through a few more defects then. We've got a few more pictures to look at. Leela talked about wet rain coming or moisture coming in from the side, what you might call wind-driven rain. And this happens quite a lot where you've got a hard render which has formed cracks because it's brittle and not very flexible, and that becomes quite a strong and effective capillary draw, taking water in and then holding it in. And when the rain passes and the sun comes out, the surface dries off very quickly, but the clue is in the little gaps around the cracks, or the cracks showing the water bleeding through from the inside, which gives you a slight indication of how wet it is on the other side. The other factor with chimneys and flues is that, as Lida touched on, some of the combustion products are quite hygroscopic. They absorb water, so if you have a bit of dampness in the wall, it tends to sort of damp up in the areas of the black and the soot and other things. So moving through, then this is quite a well-known image now, and it's the one I used to base my sketch on at the very beginning, with the happy condition and the bad condition. This is all bad, and the majority of the water here is coming in probably from the chimney head, and it's very easy to get very taken up with the wall itself. But if you don't address the bit at the top, the chimney head, and the cope, that's the rectangular stone you see at the top there, your water runs down the masonry inside, behind whatever layer you have on the gable end. So do think of the higher level aspects. And my next picture shows a particularly hairy chimney that's not in great condition. And the fact that you've got vegetation growing, the fact that the chimney cans or pots are leaning all over the place, and a slightly misguided attempt to use some waterproof paint, which in itself is peeling off. And this is a question of resiting the chimney pots, getting the haunching, the mortar either side of them properly done, and getting that drip detail, that cope, the sticking out bit, working properly, because without that you'll have a damp chimney. So my next picture down shows some really heroic efforts to address a damp corners and chimney in a village in Parthead in the Lothians, and they did absolutely everything but the bits they should have done. We had a question about what is a skew cope. Well, the skew cope is that diagonal line of, they look like paving slabs, but they're quite often stone, which goes up the shoulders of the building. The person here spent a large amount of money re-rendering and lining out and tooling to look like masonry on the gable end and also on the upper part of the chimney, but they did not address the skew copes and the chimney cope itself. You can see they are largely as original, and all of those areas had little small cracks or a lack of drip detailing. That work was done in 2017, and in 2021 I drove past, because I watched this quite carefully, thinking, God, I wish they'd done that, I wish they'd done that. And you'll see on the right hand side the render itself, or the plastered material that they put on, is in itself coming off, because detailing, the drip detailing on the chimney cope, the bit at the top, that rectangular thing on top of the chimney, wasn't shedding the water properly. And then the skew copes, the diagonals, were also not shedding the water properly. And you can see the effect that's had on the masonry and on the very expensive and quite well put on external tool render. So that's a shame, because they didn't quite address the whole thing. So moving on then, that's the end of my defect images, and we're at 12:30, so we've got just enough time for questions and things. Should we go to the chat first, and then we've got quite a long question about a Newtown basement.
There is something, Roger, that I wanted to mention a bit before, because we had some questions like, what are skew copes? So if we can bring an image up of a gable wall, and we can actually show where what a skew cope is.
Yeah, I kind of touched on the skew cope earlier in that last image, but it's the long diagonal part of a gable end with the things that look a bit like paving slabs running down the side. That doesn't have a skew cope. That's just a gable end. So my last image, the one where I was mentioning in Pathhead, the yellow building, that has the skew copes, sometimes called tabling, sometimes, and then the bit at the bottom, if you really want to know, is called the skew putt, and that holds the line of stones up. So that's a skew cope. Okay.
So we had a question from Jan on Facebook. What would you recommend for removing green staining on a limestone wall from a leaking gutter, which has now been fixed?
Not very much at all, because if the wall is dry, the green staining, the algal growth that comes around when you get damp masonry, will gradually die off and fall away. Stone cleaning and masonry cleaning is something that people are quite keen on, but our view is that if the place is in good condition, the green stuff goes away. There are some biocides out there, but I wouldn't know how to progress with that.
Also depends on the finish of the wall, but sometimes you can use a coat of lime wash, because the lime wash itself is basically prevents the growth of vegetation. It's kind of kills it off.
Yeah, lime wash is quite alkali, and the green stuff doesn't like that. So shock horror, a traditional coating is really rather good to use.
So next question was, we haven't really touched on condensation. There were a few questions about condensation, because that relates more to inappropriate repairs, lack of ventilation, overheating, and a lot of other issues that we've touched on previous lives. But Roger, do you want to add anything about condensation?
Yeah, and condensation is a mixture of 2 or 3 factors. Internal temperature. Warm air will hold more water than cold air, so the warmer the house, generally, the less condensation. If you have very poor insulation or cold areas, there will be an area. Also, poorly ventilated areas, such as sometimes press cupboards, and often behind wardrobes and things. And if your ventilation is not adequate and the relative humidity in your property is very high, water will find places to condense on, and particularly hard surfaces. So you'll see it on glass, quite often on single glazing, often on hard painted surfaces, or even cement finishes as well. So it's a sort of curious mixture of material choices, of internal temperature and conditions, and ventilation. And to get good internal conditions is a sort of cunning mix of all those variables. We don't want to be too cold, because we don't want to ventilate too much. We don't want to be hot, because that'll hold too much humidity. And we don't want to have areas of poor insulation where you are prone to condensation. I suspect we need a separate talk on that, but I hope that gets things going for now.
Yeah, thank you. Another question from Jane on Facebook. What do you suggest lining French drains with?
The modern solution tends to go for pea gravel in amongst your perforated pipe, which is fine, because you obviously want the water to percolate through and go into the actual pipe itself. I do think, though, if you have liquid water that close to the base of a wall, I'd suggest you've got problems, and I'd be wanting to get that water away, much further away from the building. I certainly wouldn't want to have a sort of an active wet trench around the foot of my wall. And if that is the case, you've probably got landscape or wider area issues where perhaps the drains go further away. But to cut to the chase, a fine pea gravel, and then topped with probably a fine aggregate, even sand. Very large pebbles don't disperse water terribly well. They've got no capillary draw. What you want to do is draw the moisture up from where it is down below and disperse it from the surface, which is partly why Leela mentioned don't put plastic sheets around the base of your house to keep weeds down, and cover them in gravel, because that prevents the ground around the house drying out, which is actually what you want it to do.
Next questions are actually very similar from Denise on Facebook and Ian also from Facebook. So they both actually relate to what you can put around your building, if not concrete or asphalt. There's no foundations because they're all buildings. Would water ingress happen if concrete is removed? And the next question that's very similar is, if a building has tarmac laid up against a gable wall, what should it be replaced with? A gutter, drain?
Yeah, so kind of two related questions.
Yeah.
Certainly, a concrete slab hard up against the wall at one level takes water hopefully away from the building, but actually, where does that water go? And in fact, it runs back underneath the concrete and then sits in a kind of area that can't dry out. So generally, what we sort of suggest is a sort of 2-foot strip of fine gravel, stroke sand. Crushed limestone is often used for sort of paving, as it binds quite well. And I think the question, would water ingress happen if the concrete is removed? I suspect water ingress already is happening. It's just you probably can't see it. And beware of trying to waterproof areas. You will never succeed. My feeling is you should be enabling water dispersal with the surfaces that you instate. And to pick up on Ian's point on Facebook, if a sandstone building has tarmac up to the gable end, that's not great, I don't think. Often pavements and tarmacked areas are operated by the local authority, and your house is sitting up against their boundary, so you can't go carving up their pavements because they'll have something to say about that. However, in a couple of occasions, folk have cut back the tarmac, again 2 foot or so, as I said, and replaced with a fine aggregate. Crushed limestone is quite common, I said, as it binds well, or a sort of light sand and fine gravel mix. If a gutter and drain really tries to address liquid water from somewhere else, and I think that may be necessary, but I'd be looking at dealing with that further away from the building, possibly the slope above or something.
And to add on Denise's question about would water ingress happen if concrete is removed, as Roger mentioned, it will help sort of the evaporation, but you will need to see where the water is coming from and why it's getting so damp.
Yeah. Rain falling from the sky on its own onto earth won't make that flood or pond particularly. It's whether all that water is gathering up and running down a slope to your back door. That's kind of water from somewhere else.
Next question is related to NHL. So NHL is natural hydraulic limes. So Kate on Facebook is asking, what are your thoughts on using NHL 3.5? And there's so much negativity about it at the moment.
Yeah, I mean, an NHL, natural hydraulic lime 3.5, so that refers to its compressive strength in kilonewtons after 31 days, I think. So what that's saying is that there is a binder for a mortar that's reasonably strong, and different binders and different mortars are used in different areas. We touched on chimney pots earlier. I'd be haunching my chimney cans in something quite strong. I'd be pointing my walls and plastering my walls with something quite much not quite so brittle and strong, something that was able to shift vapor and be capillary active. and NHL is sort of on the sort of the harder end of the middle in terms of binders. So there's nothing wrong with it. It's just where you use it and what you use it for. In some cases, gauging a traditional quicklime mortar with NHL is absolutely fine. In some cases, you might want to use NHL on its own, depending what you do. But it's horses for courses. Most traditional mixes for masonry work is a quicklime based, gauged with a natural hydraulic lime to give it a little bit of set. There's a whole world of discussion about mortars, traditional mortars and stuff, which we're very happy to take forward, but probably
maybe we
time.
maybe we can do a live specifically on mortars, because we've had a lot
we can
about it.
Yeah, we can get ourselves tied up in knots in that one. That'd be great.
Next question is from Jennifer on Facebook. They have a 1900s house. Kitchen at the back has concrete floor. Ground outside has been raised. Someone put a concrete patio. Low-level cupboards in kitchen now get damp. Without massive work, would adding air bricks lower down help?
Well, air bricks are to ventilate a suspended floor, to get the air in underneath the floor. And if you've got a concrete floor now, I don't think that would do much. This is probably a ground level question, isn't it? And water coming off the concrete that the new concrete patio area has created, and maybe running it to the foot of the house, which is just not very good. Without massive work, wouldn't really want to go much too far there, apart from say massive work might be the necessity, possibly. Checking, of course, that the water you're getting in the kitchen is definitely from outside. Again, defective services, internal water pipes and heating can quite often contribute to water under your feet inside your house that you don't quite know about.
We had a question that's not very related to this. It's about external insulation boards versus internal insulation. We have talked a lot about insulation and improving your building for energy efficiency in a previous live, but I don't know if Roger feels like giving a bit of a summary.
Yeah, we could do. We're not too bad for time. So I think most people agree that from a building physics point of view, external wall insulation is probably better. And you could also argue that in Scotland, many external walls are not in very good condition and need a bit of work. So you have to get the access, the scaffold up there anyway. And indeed, in Scotland, many traditional buildings before 1850 had some, 1850-ish, had some form of external render and plaster. And you could say, well, why don't we just pick up on that with a bit of EWI? Internal insulation is good too, because it's sometimes more convenient. It may be more something that the homeowner or the occupant can kind of commission more easily, particularly with some forms of blown material that we've tried. And it may be that the answer is a little bit of both, or indeed it may be that your external wall is ashlar work or decorated in a certain way or has a certain finish that you couldn't really, for various technical reasons or aesthetic, you wouldn't want to cover up. I think it's probably one to be explored another time, but there's benefits in both, and it's kind of situation dependent to a certain degree. Most of our work has done internal wall insulation, but there are many opportunities for external wall insulation. So if you remember that yellow cottage that I showed you with the peeling render that was falling off, maybe if that was addressed and the copes and the chimney head were addressed, you have options for something external wall insulation there.
So we had a question from Facebook about basements. If the building is already pointed in lime and there are vents, how can the moisture be regulated?
Quite a hard one there. We get quite a lot of questions about basements, and generally, if you've got liquid water coming in, you've got a drain problem. And again, nobody wants to look at drains. It's highly unfashionable, but I'd suggest that's the best use of your money. and the best way to get a building interior that is not wet. It's also about managing the vapor movement through the wall on a basement, and we very quickly get to what is the nature of the surface covering on that wall. If you've covered that wall in oily paint, that won't shift any vapor. The vapor will build up in the matrix of the stone, will condense, the paint will blister, it'll probably smell, etc., etc. So you've got to balance allow that vapor to move around, so that you have a sort of stasis of the average vapor in the earth, being able to move around either out into the garden or to some degree vapor movement through the materials and out to the internal face. I can see.
Yeah, before we go to the next question, Roger, because that's very similar to a question we received via email from an architect in about an Edinburgh Newtown basement. He was dealing with some cellars that have been previously tanked and are dry and well used, but the walls now below the pavement and the bridge to the property are badly affected by damp, and their cause for concern. They have also been painted, likely with a non-breathable paint. Stone is delaminating, and the architect is suggesting to sort of drain. But water is still pouring into the basement area when it rains from the pavement and through the cracks in the stone slabs.
Yeah, I think this is a complex geometry question. This is a street drainage question. Water pouring into a basement. This is not a building. This can't be solved by building fabric and all my chat about vaporness. This is about getting the drains working out in the street, which will involve, in Edinburgh, will involve other stakeholders and probably complex geometries with respect to the basement, where it sits on the elevation, and indeed the other things around it. So I think might have to kind of hold on that one, might be able to help with a couple of pictures and give a few steers, but that's probably the limit on this for now. Okay, did I see a question about something about 1610?
We have two questions that have come in. So first one, our internal walls have patches of peeling paint and salts collecting around base in some areas. Stone construction with lime mortar and lime plaster, sticks in 10. Any remedies, please?
I think this might depend on what the paint is and why it's peeling. The fact that paint is peeling suggests that it's an oil-based paint, or probably many, many layers of emulsion, which doesn't shift vapor terribly well. And the salts suggest that there is a more liquid water coming in somewhere, and the salts are forming at the drying edge, drying layer. Back to drainage, external ground levels. Again, it's I think any remedies could not be given without the wider context and some feeling for the cross-section of the wall and indeed the internal floor. Many buildings of this date were redone in the 60s and 70s, and their go-to solution was a poured concrete floor, which is a very good way of concentrating moisture into the walls. So that might be the first aspect to look at. What's the material composition around the wall, and what can you do about it? I suspect removing sticky oily paint and replacing it with a lime wash would be a very good start.
Next question is from Fiona on Facebook. You mentioned trees next to a wall causing problems. What is the problem here, please? Is it okay if the tree is not touching the wall?
Yeah, so this was a cottage that we did work with in the National Trust some time ago now, and it's quite often not the tree per se, although it can be. It's the sort of general indicative nature. So the tree was very overgrown. The ground level up against that bedroom was about a foot higher than it should have been. The tree in leaf was preventing the sun and the wind getting onto the wall, so the wall was becoming a little bit damper. I think it's not about physical damage from the tree itself, although obviously you don't want branches crashing into your masonry. And also remember the roots. Where are the roots going? And are they moving around and getting bigger, because the roots get bigger as the tree gets bigger, and are they moving and lifting stuff? So generally trees hard up against houses is not a good idea, genuinely, I don't think, generally. and they should be, good 10 feet or so away. And of course, a sapling, a sycamore will grow in 10 years. You'll have really something quite big around your house. It doesn't mean it's right.
Another question from Paul on Facebook. In your preferred example, the house you drove past, when you say address the coping stone, how would you address it?
Yeah, so I think the bit they missed, particularly on those diagonal copes, as we call them, the fine joint between each one was clearly not addressed. And as I watched the building evolve, I could see the ingress points. And it's curious, this type of pointing is called ashlar pointing, and the gaps are about sometimes 5 millimeters or so. And to address it is pretty simple. You trowel in a very fine lime, putty, and sand mix, like how do I describe it? Like sort of stiff toothpaste almost. And you push that in with a very fine trowel, and you seal up, you close up that open gap. The other thing is the projection from the wall, which actually in this case is quite good. And then the chimney head itself, if we just move up to the top of the chimney there, the rectangular piece of stone or concrete on top of the chimney needs to stick out quite a lot and shed and drip water, and this one isn't doing it. You can see the streaking down the side. It just isn't doing it, and those two elements were not looked at by that contractor. And I think probably the best answer for that is to go to our short guide 11, climate change adaptation for traditional buildings, which has endless pictures of building drip detailing, because we love it, and it's really, really important. If you don't get the building drip detailing right, which is part of its architecture, and many architectural features were concerned with shedding water, the materials just don't work, whatever materials you use, lime, concrete, or whatever.
We have a question that's a little bit not relevant to this session, but if you have some time, we can answer that. What is the best way to remove non-breathable paint from internal walls?
It depends what it's on. If it's on plasterwork, internal plasterwork, perhaps lath and plaster, it's actually quite hard to get off. Sometimes your sort of steam stripper can soften oily paint quite well. Sometimes it's been thrown off by the earlier paint layers, the softer distempers and powdery paints underneath, which actually just throw it off. If it's on masonry or a harder material, that's quite difficult. Often what you might do is scrape off the bits that are flaking, and then use a proprietary paint remover on the other harder bits. But yeah, large scale removal of oily paint from internal walls is a bit of a challenge, and I don't have an answer, which is why we try and get people to put lining paper on plasterwork, so that if you change your mind or you want to change the color and someone's got the wrong paint on it, it comes off with the lining paper. Life gets a whole lot easier.
So next question is from Fiona on Facebook. They have a 1935 flat roofed Art Deco house with solid walls and concrete floors. They've had all the drains relayed and dug out around the house. Sorry, I lost it. Around the house to below the bitumen damp-proof course, laid gravel, and put in a sand pump. It flushes every 10 minutes during heavy rain. They get a lot of groundwater flooding in the garden in the winter. These measures have helped a lot. However, they have water ingress above a window. As there are no gutters, we are wondering where it is getting in.
Well, the fact that the sump pump is hard at work suggests that the perimeter drainage is not working, because this thing is not meant to happen. I'm telling somebody to go away here who wants some lunch. Yeah, so something's not quite right there, the fact the sump pump is so active, because ideally your drainage gets this stuff away. And if it's, perhaps you're getting other people's water running off a slope and a hill. As for water ingress above a window, that's a bit harder without any context. I couldn't really speak. And generally, although some architectural styles have no gutters or roans, they're generally necessary to get water away from the building edge.
I suspect if there is a flat roof that there's no detailing there to actually shed the water away.
Yeah, quite hard to say with this one without images.
Yeah, maybe we can take that offline. You can send us a few images and we can see if we can help.
That's perhaps the best way. A few pictures and context. Yeah.
Next question is from Jane on Facebook. They've had timber windows replaced in November 2020, and there are now damp patches on the reveals next to the windows for a couple of them. The windows were installed by a local builder. We tried sealing the outside, probably using the wrong products. Where would you suggest we start in trying to fix this?
Timber windows replaced, damp patches on the reveals next to the windows for a couple. Yeah. Generally, the junction between a window and the masonry needs to be closed, and often traditionally it's a sand mastic type. Some people do use other materials. On the whole, though, depends on the orientation. You shouldn't get that much wind-driven rain pushing through those gaps, though. It's slightly unusual. Again, I think that's a little specific, and you might have to send us a couple of images just to help us along there. It generally isn't about sealing something tight. Obviously, closing gaps and things, yes, but sometimes windows get blamed for other issues occasionally.
Okay, maybe we can take one last question if there is any, because we're getting close to the finishing time. So we'll give it like a minute and see. As we're waiting for maybe one last question, I just wanted to point out again that there's only going to be one more session before summer, and this is going to be open for just generally questions. It would be best if these are questions that relate to previous lives. Feel free to go and view them again, and if you feel that there's something that hasn't been answered that's relevant, please ask us then. You can email us beforehand at technicalresearch@has.scot, as we've said before, so we can discuss that. If you do send us pictures because they do really help, please indicate if we have permission to use them, because these lives, they do stay on the web, so we do have to have permission to use them.
Yeah, we love your horror images, particularly if they involve drainage, as I said. So yeah, let's go. And again, have a look at some of our publications, particularly the Inform Guide for Damp and the Climate Change Adaptation Short Guide, because that covers most of the areas that we've discussed today.
Yeah, and there's a question about recommendations on literature on detailing. So we do have this short guide on adaptation. I'm not aware of other ones, to be honest.
Yeah, it's kind of slipped from the architectural canon, but when you look at most traditional architecture or historic architecture, particularly Gothic architecture and particularly classical, it's all about edges and shedding water. Some really good examples of rainwater detailing from classical Greece, for example, or indeed from early medieval buildings, where when you look at the decoration, it's actually configured and shaped to put water away from walls or to shed it in the right direction. Generally, as you get into more modern period buildings, there's been a less of a focus on that level of detail and more on the overall bigger architectural composition.
Exactly. So I think we're going to finish here, and I would like to thank Roger again, and thank you to everyone who joined us for this event. We hope you enjoyed it and you found it informative. A bit of a different structure this time because it was a different issue. It would still be great if you could fill out the survey that will be posted in the chat, because it really helps us with planning these sessions. And as we mentioned before, next session will be slightly different, just going to be questions and answers. And that's going to be the last one before the summer. So as we've said many times, please send us a question on technicalresearch@has.scot. And thank you for joining us today. Thank you, Roger. And I hope you have a good rest of your day.
Cheers, team. Bye.
Bye.